basically Wednesday, but I want to take through something all the way through, sort of from beginning to end, including the GUI. So we're going to talk about a game that I cover in a number of my classes. Let me see if I can find an online version of it to play. Or to talk about. Yeah, that's not it. Well, finding videos and stuff, but probably could just as easily describe it. The way the game works is like this. You roll 2 dice. Dice, regular 2-sided die, can have a value of 1 through 6. So you roll 2 of them. You have 3 choices. You can say it's going to be low, the total of the 2. It's going to be low, which means 2 through 6. You say it's going to be 7, which means 7. Or you say it's going to be high, which means 8 through 12. You get paid 1 to 1 if it's low and you picked it. You get paid 4 to 1 if it's 7 and you picked it. You get paid 1 to 1 if you picked high and that's correct. So as you can kind of see, the odds are stacked against you, right? Because the odds are slightly less than 1 to 1 that you'll row. The odds are actually, let's see, how many possibilities are there? There are 11 possible rolls of the dice, right? 2 through 12. Actually, there's 36 possible rolls of the dice. 15 of them are going to be high. 15 of them are going to be low. And 6 of them are going to be 7. So your odds of winning are actually 1536, which is lower than 1 to 1. So you're getting paid less than even money. You're getting paid even money, but your odds of winning are less than 50-50. Likewise with high. And you're getting paid 4 to 1 when your odds of winning are 6 to 1 with the 7. So it's a losing game, as all gambling is. So if anything, I will have taught you that lesson. All right. Let's talk about how we're going to develop this game. All right. We're going to do it in a couple different passes. All right. This is your game to do. Or if I was going to make a project for this, to give it to 2 or 3 people, how would we proceed? What classes do we need? That's sort of a good place to start. What classes do we need? We need a dice class. Okay? So, we're going to have a dice class. What else are we going to have? A main class. And the main class is going to serve to be our GUI. Or we have any other classes? Good program design suggests that we would have at least one other class, and that would be the game class. All right, so that's what we're going to do. We're going to develop these three classes. Here's sort of the idea behind this and why we developed three classes. Could we put all the logic in one class? Yes. And we could make just one gigantic class that has everything in it. The problem is when we're done with that, we would have no components that we could reuse. We could only run that if we wanted to play that game. We will not put us any further for playing or designing any other game class, any other games, right? Any other dice games, like Yahtzee or whatever, craps, or any other game. Whereas if we develop a dice class, then that's something we don't have to do going forward if we have to develop any other ones. We develop a GUI because, well, of course it's going to need a GUI. Why not have the logic in the GUI, though, for the game rules? Well, the idea is what if we wanted to run the game with a different GUI? We wanted to incorporate it on a web page, for example, which you can do with JSP and Java servlets and things like that. You know, what if we wanted to incorporate this into an Android application, and we wanted to use the Android framework to develop a UI for all that? An important notion in object-oriented programming is what's called encapsulation. And we've sort of talked about that a little bit. But what that relates to is everything about a certain entity will be in a class. And you're not going to mix stuff about different entities into a single class. And sort of a corollary to that is the separation between your problem domain logic and your user interface. User interface is your user interface, all right? Your problem domain classes, or business classes sometimes they're called, if it's like for a business problem, that logic ought to be separate from the user interface. So that way we can plug those classes into any user interface we want to, all right? Now we're going to do this a step at a time, and we're going to test it a step at a time. We're going to do unit testing, and then we're going to bring everything together, develop the UI, and do system testing. So we're going to sort of take this project throughout the entire class that we've done since the first day of class and end up with the user interface. Because we talked about the user interfaces a little bit, but we really didn't spend a lot of time, and we didn't do anything terribly extensive with it. This one will play around with user interfaces, and we'll do different things that'll make the interface look better. So let's start off. I'm going to, first class I'm going to make is, which one do you think we should make first? We could make the main. I'm asking you, but I'm going to do what I want to anyhow, so that's kind of, I don't even know why I bothered asking. Sorry about that. I'm going to make the dice class. Why the dice class? Well, because I think I can write a dice class and test it really thoroughly and sort of get that one out of the way. And then that will be my component that I can use. And I'll know I have dice at work. All right? So let's write a dice class, and we will test it. And we'll write unit test code for it. And then we will incorporate it into the game class. And then we'll work on the user interface. Now, if we had two people working on this, just think of how neat this could be. By neat, I don't mean like neato or cool or something like that. I mean, think how clean the separation between the stuff is. All right, because we could have one person work on the user interface and have a different person work on the business or problem domain classes. So I'm going to start off by writing a dice class. Now, what should we put into a dice class? What are the properties and methods that we should have in a dice class? Remember, properties are things that the object, that the member of the class knows about itself. And methods are things that it can do, or, yeah, it can do.
You would have attributes and constructors and sets and get.
Okay? So public class, and I know the actual word is die, but I hate writing public class die, so we'll call one of them a dice, all right, even though that's grammatically not correct. What attributes does a dice have? Yes? Face value. Okay? Now,
always got two, so how would you quantify that?
what do you mean you always have two?
Well, if you're going to throw dice, I'm assuming you're going to be throwing two. Or
Okay.
Logic.
That's absolutely correct, that you will have two dies, all right? So how did we handle it with pizza? We sometimes had two pizzas, right? We sometimes had two pizzas on the order. So how did we handle that? In the case of a pizza, it was a variable number of pizzas. We didn't know how many were in the order. But we had a separate, in a broad way to answer that question, we had a separate object for each pizza. We'll have a separate object for each dice. So to do a pair of dice, would have two of these objects. There's one class, right? Because all dice in the world share some common characteristics. They have a face value. You can roll them. You can get the value of the face value, right? You can get the value of the dice. So those are the properties of methods. Those are the things you can do with a dice, all right? Now we're going to have two of them, all right? So we throw dice 1, we throw dice 2, all right? So that sort of gave a hint to some of these methods. I'm going to create a public int method to roll the dice. How do we roll the dice? We assign a random value between 1 and 6 to it, right? So how do we do that? It's going to be something like this. We're going to set the face value equal to math random times 6 plus 1. Make that an integer. I think this is going to give me a value 1 through 6. Why do I think that? Because math random is going to give me a number from 0 to 0.9999999. All right, that's what math random does. If I multiply 0 through 0.9999999 by 6, I'm going to get a number from 0 to 5.9999999. So from 0 to almost 6. I add 1 to that. I'll get a value from 1 till almost 6.999 or almost 7. If I truncate it and make an integer out of that, I will get a number from 1 through 6. Okay? And should be evenly distributed. All right? We're going to test that out, by the way. Right? Because, well, you know, better not have a loaded dice in this game, right? You know, better be an honest dice. So we're going to test out. And testing stuff that has randomness built into it is hard, right? So we'll look and we'll see how we can test something that's random. All right? So and I'm going to return the face value. I'm going to put a get in it that returns a face value without rolling. So we could roll the dice, and maybe later on we want to know what the face value was. So we're going to get a roll, get the value of the last time it was rolled. I'm not going to put a set in there. All right? I guess I could. Like I could put a set in there to set the value, but I don't really see the need that I would ever want to set the value of a dice. All right, manually. I'm going to put a constructor in here that accepts no arguments. It simply rolls the dice. So it's random from the beginning. Let's say I have a pair of dice I pull out of my pocket. Here you go. What are they going to be? I could assume that they're going to be randomly set at something. So that's what the value of the dice is, what I created. It's just random. Okay, so I got this. I have a constructor, I have a roll, and I have a get method. So how are we going to test this? Let's save this in here. I'm going to write a dice test class. And again, this is going to serve the role for the GUI, right? If I had the GUI done, like someone suggested I do, I could plug that into the GUI. But I have this, and I'm ready to test it, but I don't have a GUI. So I'm just going to write a test class, which again is going to have a public, static, void, main, that accepts an array of strings, and goes ahead and does something. Well, what am I going to do with the dice? I'm going to create one, roll it, and see the value. So I'm going to say dice D equals new dice D.roll. And just for laughs, I could say something like this. System.out.println D.roll. Println D.roll. Okay.
I have a question.
Yeah.
So since the constructor of the dice class already has a role in it, when you create it, do you have to do the dot roll again? Or could you just do a get to get what
I could get it. You're right.
Okay.
I could do it that way.
Just trying to
Right.
do it either way.
You could do it either way. That's true. I know what's going on inside the dice class. It could be the person writing the GUI or writing the user of the class doesn't know what's going on inside of it, though. So I'd want to roll it to be sure. Because maybe it defaults it to 1. Maybe, so. Now let's go in and compile this. All right. Roll to 1. Roll to 1. Roll to 1. I was wrong. Does that seem interesting to you? All right. Let me explain to you what happened, then let me give you the bigger lesson here. All right? Here's what happened. It's a matter of parentheses. Originally, I didn't have these parentheses. So what did that do? It converted this into an integer, which is always going to be 0, right? Because this is a number that's 0 to 0.99999. If you convert that to an integer, it's always going to convert to 0. 0 times 6 is 0, plus 1 is 1. So I put parentheses around this. That did this whole expression and then converted it to an integer. So it took point whatever times 6 plus 1, and you might get a number like 3.5278 or whatever, all right? Then that got truncated to an integer, and you'd have 3. So, a couple things about this. Boy, it's great to find that bug out 5 minutes into the process instead of 3 days into the process. Okay? So, hey, could you imagine if I wrote everything? All right? If I wrote the whole program, user interface, dice, game logic, had 3 different classes, and had maybe 100 lines of code between them, and I was getting a bug that it always showed up as 2. Where could the problem be? The problem could be anywhere, right? I could have screwed things up in the game class. I could have screwed things up in the UI. Could have screwed things up in the dice class. It would be very hard to tell for sure that that was correct. So instead, we're going to unit test everything. We're going to test to make sure everything as a unit, to as great a degree as possible, works. When that works, then we start combining things. All right? So we find errors, we find fundamental errors like this quick, and we don't try to combine things together until we know each little component works. Okay, so I ran this through a bunch of things. I'm getting a different number each time. I mean, I'm getting some repeats, but that would be expected if you were rolling a dice. Am I happy that this works? Can I put a line under it and say that this works? There's really nothing that could go wrong in this. I jokingly say, logic-wise, there's obviously a logic error in this. But as far as things that would blow up, I don't see any exceptions that could happen. All right? We're generating a random number and we're doing a math operation on it. We're not dividing by something that could be 0. We're not having any null object references or anything like that. So I don't think there's any kind of exceptions we could throw here. Here's what I'm saying. How many is enough for me to guarantee that this is random? All right, I ran it through how many tests? 20 tests. And it looked random to me. Maybe the code is wrong, and maybe it's returning lower numbers more often than it's returning higher numbers. Can I say that after running 20 tests? I could go back and count these. But we got a computer here. Why not let the computer do something absurd? Like run 1,000 rolls of the dice and see how many it gets of each. Why not? Can we do that? Sure, we can do that. So what I'm going to do is I'm going to create in my test class. Now, I've said before, you don't necessarily try to write a test class that's great. You can just get one that works. So in that spirit, I'm just going to write int counter 1 equals 0. Create 6 counters. I could make an array without too much sweat, but again, So I'm going to print it out, and I'm going to say if val equals, let's do a case statement. All right. I don't think we've done any of these this semester. So let's look up Java case statement. Case statement is a nice way to choose between mutually exclusive values. It's actually a switch statement. My mistake. So I can say switch my switch is on val. I'll check the value. If the value is 1, I want to increment counter 1. And I know the cool kids say counter 1 plus plus, but I learned it this way. And I know I could do this slicker with an array, but I don't care. Because this isn't code I'm going to reuse anyhow. I'm just going to test it. If I ever change my dice object, maybe I'll dust it off and run it again. But this isn't like code that needs to be great. It's just serving the task of testing. Two, 3, 4, 5, and 6. And I'll change these values, counter 2, counter 3, how do I test the test code? Well, I'm not going to do 999 the first time. I'll do 5 the first time. Yeah, 3. There you go. Thank you. And then I will print out my I'll print out my 6 counters. Now I'm going to eyeball it, make sure it's right. I'm also going to only run it 5 times the first time. So make sure if I made a dumb mistake in my test code that I'll be able to eyeball it.
Have to initialize the values to 0 since you're going to be printing them out. Oh, you did.
Yeah.
Never mind.
All right. 1, 3, 4, 1, 4, 5. Three, 4, 1, 4, 5. That's the 5 times I ran, right? So it's giving me 0 ones.
Maybe it didn't hit one of the counters because you only ran it 5 times.
Well, yeah, but I can clearly see I have a 1. All right. Case value, D roll, print out, print out D roll. I should print out val. I rolled it twice. All right. All right. I rolled a 5 and 4 6s. 5 and 4 6s. I rolled a 3, a 1, 2 6s, and a 2. So I should have a 1, 2, and 3, no 4s and 5s. And I rolled 2 5s, 2 2s, and a 3. 2 5s, or 2 2s, a 3, 2 5s. Okay, so I'm pretty sure that that code is right. Now, I'm going to go and run this. Over a big enough number, what should happen? Should even itself out. All right. So is it going to be exactly 1/6 for each of them? No. All right. But if I notice that of the 1,000 times that I run, 800 of them are ones, and the other 200 are spread around the other 5 things, then I probably did something wrong. All right, it's going to go for a while. 162, 180, 175, 165. You could, if you were studying statistics, you could probably see is that within the expected values. Or I'm going to comment out the writing out, and let's run it 10,000 times. The more numbers we have, the more it should get to be evenly distributed. Pretty evenly distributed. All right, so I'm happy with my dice object. All right, so now I can go to my game object. What's my game object going to have? Well, if I was playing this game, what would I have? What would I have in my hand? I have 2 dice, and I'd have in my head the rules. So the attribute would be the 2 dice. So I'd have 2 dice objects. I would have a way to get the value of the dice objects because I need to display that on the GUI. Then I would have a way to say, did I win or not? All right? And how much did I win? So, my game, we'll call this high-low game, will have 2 dice objects. And we'll have a play method that will accept a bet, which is an integer, and will accept the choice. Now, what could the choice be? The choice could be 0, 1, or 2. So low, 7, or high. I'll represent a choice of a 0 as low, a choice of 1 is 7, and a choice of 2 is high. All right? So that's what I need to give it to play the game. I'm going to have two other methods. It says get dice 1 value and get dice 2 value. That's probably all we need. So let's go in here. Let's create a class. Public class high low game. Dice D1 equals new dice. So there's our pair of dice. This is Yahtzee, would have 5 of them, all right, or however many number would be appropriate for the game. I don't know if I need a constructor on this. I can't think of anything I would default, all right. So I'm going to say public int play. Int is the choice. And int is the bet. Okay. So, how do you play the game? It's the first thing you do. You got the choice. So I have in here that I'm betting $1 and I have chosen low. So how do you play the game then?
You would have to create what, now that you've got your choice, the first thing you have to do, I would think, would be to create your rent is to play dice 1 and play dice 2.
Right. So again, sometimes it's useful not even to think in programming terms. If we're playing a game and I said I'm betting it's low, I'm betting $1 that it's low, what would you do? You'd roll the dice, right? So we're going to do the exact same thing here. So I'm going to create my 2 values. And I'm going to get that from rolling the dice. All right. Now, I'm going to say, then I'm going to sum the dice. So if hard choice equals 0 and sum is less than 7, I have a winner. All right. And what's my payoff? My payoff is whatever I bet, because I get paid 1 to 1. So payoff equals arg bet. I'm going to revise this if statement a little bit. Because if the choice is 0, if sum is less than 7, then the payoff is whatever they bet. Otherwise, the payoff is -1 times the bet. Well, no, this is only the low scenario.
Oh, okay.
So we're going to have 3 of these if statements. Maybe a comment would be good here. All right. Now, choice of 1. If the sum equals 7, then the player gets paid 4 times the bet. Otherwise, it costs them their bet. And then finally, if the odd choice is 3, or 2 rather, and the amount is greater than 7, then their payoff is just their bet. And then when I'm done, I'm going to return their payoff. All right? I'm going to have 2 functions to get the values of the dice. Because I certainly wouldn't want the game to just say, you lost, you lost, you lost, you won. I'd want to show the dice, so I know if I'm being cheated here. So, what is dice 1 value going to return? No, you're right, you're right. D1 get value was the name of the method. I'm pretty sure anyhow. Yeah, D1 get. I don't even have get dice, get value. I just say D1 get. And the value for get dice 2 is D2 get. There's a few different ways you can do it. This is probably the simplest. This is known as delegation in programming, right? In other words, my UI is going to ask the game, gee, what were the values of the dice? The game's going to ask the dice, hey, what were your values again? So the game object sort of delegates that functionality for there. It would be like a car has certain size tires, right? You could ask a car, hey, what size are your tires? The car would probably say, hey, tire object, what's your size? And then whatever size the tire returned, that would be the size that the automobile would return. So that's delegation. All right? Okay. So we should be good to go on this. I'm going to save this as HighLow game.
You don't need to print the value. You will know what they are.
Well, remember, this is a component.
Okay.
Am I going to run this from a test class? Am I going to run this as part of a UI? What kind of UI am I going to report and all that? Again, it's a separation between the business logic and the UI part. In the case of the dice, were there any print statements inside the dice class? No. It returned the value. My UI, or in this case my surrogate UI, returned and did the outputting. So, I'm going to call this HighLow. Game. All right. Now, I got to test this. So, I could put this as part of the dice class, or I might make a different test. I'm going to make a different test object. Again, the whole idea of this is it's sort of throwaway code, these test objects. So I'm going to make a HighLow test, HighLow game test. So I'm going to start off small with this, and I'm going to say HighLow game G equals new high-low gain. And I'm going to play it. What the heck? I'm going to say int payoff equals 0. Payoff equals G. Do I want to pick high, low, or 7? Let's say I'll pick low. So 0 is low, and let's say I'll bet $1. G.play, I'll pick low, and I'll bet $1. Let me get the value of the dice 1. In fact, I'll do this. Let's at least get through one iteration of this. I don't know. Sure, we can put a space there. So we'll say what the bet is and what the payoff is. Okay. This is high-low game test. .java, we'll save it. I'm going to compile everything for good measure. Could not find that. It should be Java C. Missing return in high-low game 47 and 51. Oh. It's just a concise way to say, call this function, get the value, and return it without having to define another variable. All right. I rolled a 6 and a 4. I bet $1 on my pick, and my pick was low, so I lost. 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 I won. All right. Again, notice it seems to be working, right? But like with the dice, we could easily go and write some code let's run this 1,000,000 times, or maybe not 1,000,000, but 1,000 times. Let's see where we're at. That's what we'll pick up next time. Sorry I didn't get as far as I thought. I should have known better. Everything takes longer than you think. All right. We'll get into the UI next class for this one. All right. See you in lab. I just noticed that I was not on the computer for this video. So you're going to be looking at that. If you watch the video, I apologize. You will not be able to see the code, but the code is posted to Canvas. You can download and look at it. All right.